Hey, welcome to your Kin 225 lecture for today. What I'm going to cover is the slides that I did not cover last day. So I'm going to start off with muscle fiber typing based on metabolic properties. I've already covered muscle fiber typing based on myosin heavy chains or ATPase activity at the myosin. I've also covered muscle fiber typing based on twitch properties, so slow twitch, fast twitch, how fast the muscle contracts when it's stimulated. This is another way to classify muscle fiber types, and it's based on metabolic properties. So you have different types of enzymes inside your muscle fibers. Outside the mitochondria, in the cytoplasm, you have what are called glycolytic enzymes. These allow the fast breakdown of carbohydrates and give you a small amount of energy. So enzymes are proteins that allow chemical reactions to go faster. Without them, your muscle contractions would be really slow, so they allow you to have a faster muscle contraction. Metabolic byproduct you get when you break down carbohydrates is lactic acid. So that's the the burning sensation that you get when you do high intensity exercise for short durations because of that lactic acid buildup. And this is typically in a fast twitch fiber or a type 2 muscle fiber. So these enzymes are high in a fast twitch or type 2 muscle fiber. Inside the mitochondria, we have oxidative enzymes. So these enzymes are involved in aerobic metabolism. So in the mitochondria, you get breakdown of carbohydrates, protein, and fat. It's a slow process, but it gives you a lot of energy. So it gives you a lot of ATP. And you get a low amount of lactic acid. And this is typical in a slow twitch fiber or a type 1 muscle fiber. So when we do this classification based on metabolic properties, we call the muscle fibers slow oxidative, the ones with a high amount of mitochondrial enzymes. On the other end, we have fast glycolytic, low amount of mitochondrial enzymes, but high glycolytic enzymes. And then you have that intermediate fiber called fast oxidative glycolytic. So if you look at the other classification schemes that we've covered, first of all, based on myosin heavy chains or ATPase activity, then twitch properties, usually a slow oxidative fiber would correspond to a slow twitch and would correspond to type 1 fibers. A fast oxidative glycolytic would correspond to like a fast twitch A or type 2A fiber. And then fast glycolytic would correspond to your fast fatigable, your type 2X fiber in humans, type 2B fiber in some animal species. Another metabolic property to look at in muscle fibers is this protein called myoglobin. So myoglobin is a protein in your muscle that is responsible for transporting oxygen from the muscle membrane capillary interface to the mitochondria. So it will take oxygen and deliver it from the capillaries that feed your muscle and bring it to the mitochondria where it's used to break down carbohydrates, proteins, fats for energy. And myoglobin gives the muscle a red pigmentation. And it's going to be your slow oxidative type 1 slow twitch fibers that have a high amount of myoglobin. So a good example of that red pigmentation that you get in the muscle is this is meat from a pig. So this is pork, and it's just different cuts of the pork, so different muscles in the pig. You can see on the right hand side the meat is very red. On the left hand side, the meat is quite white. So this would be more of your glycolytic type of muscle, and this would be more of your slow oxidative muscle. And you can tell it's slow oxidative because it has that red pigmentation, and that is because of the high amount of myoglobin, whereas your fast glycolytic muscle has a low amount of myoglobin, so it's more white in color. So your more aerobic muscles are red in color, and your more glycolytic muscles are white in color. So you see this big difference in a lot of animal species. In humans, most of our muscles are a mixture of fast and slow fiber types. So you don't get the huge contrast in human muscles. You can also look at capillarization to differentiate muscle fiber types. So the difference between fiber types is that your slow oxidative fibers are surrounded by a greater number of capillaries, and this allows them to receive a greater amount of oxygen to support aerobic metabolism. And I will continue with this force-velocity relationship in the next part.